And hi, everyone. So we probably can start for today's topic. So in today's meeting, I want to present basically called the distribution transaction. So basically, Fangming is my colleague, and I'm Eddie Ruan, and this is Fangming Tai, and we from Cisco. So we wanted to present what is the distribution transaction we want to add in the audio, the framework. This is more like a small enhancement in the audio as a framework. So what kind of functionality we want to add? So when the first time when I have my own like audio project, so what do I want to do is basically I want to use in the audio as a platform to manage a set of the white boxes. So it's a bunch of small boxes, could be like a virtual, could be physical. Those are the small boxes in the network. But I want to use the audio to manage it. So once I manage it, I want to like say use it on top. There will be the virtual router to looking at the route to managing this network as a router instead of managing each in different boxes. So then in that case, so when the customer configure, it will be configured instead of configure the network, he'll configure as the top overlay network, the router. But once he configure the router, I need to converting those configurations through the ODO to different devices. So then that means that, say, for example, I configure the layer 3 VPN that on the top virtual router, which is peering with the external guys. Then go through the ODO, he thinking this is more like, say the services intent, which kind of similar to the granted idea. So this is the intent, but then we need to convert into the devices. I could say, for example, I have like 10 devices which on the underlay, which need to be programming this one. It could be go through netcom, could be something else. So, but the question right now, the problem I'm facing is like, say, how do I provision it? Right now in the netconf, when we programming it, we program one by one. In the normal case, it should be okay. But once the error happens, then application need to be aware to say, okay, I need to roll back. Say, for example, I have like a 1, 2, 3 success, fourth one failed. That which means that I need to roll back 2 and 3 as well. That's what we call the atomic, means that the operation need to be done either all success or 0 be put on the network. So that's the one thing we want to do. It's like that's what we call the network level transaction. So either all success or all fail. So it cannot be leave something in the middle. Because if we don't have that one, so which means at the end of the application need to do all this by themselves. So if you have like a 1, 2, 3 success, fourth fail, then you need to, okay, I need to roll back 3, 2, and 1. But if I have like fifth success, then which means you need to roll back 4, 3, 2, 1. So it's kind of like say each application do it by their own. So right now we want to introduce this as the infrastructure to doing it. Then the second one is the isolation, so which means that once I start to configure these devices, which means it's kind of like each individual, when you do the netconf, you have the lock. When you get a transaction, you have the lock. This is one thing, if I want to programming these 8 devices or 10 devices, I also need to grab the lock to make sure that no other people are touching these 10 devices. You don't want like 2 brains, so which means one guy getting updating the one part of the config, the other guy simultaneously update the other part of the config. That will be cause a problem. That's why we call it isolation. So the main thing is very simple. The 2 functionality we want to achieve from the network wising. One is atomic, one is isolation. Basically say, I want to make sure that I could really treat the network as one entity or one device when we're programming it, instead of like say, handling 10 devices differently. So from the requirement point of view, so one is compatible. So we need to, so if you're looking on the current DL, like let's say framework, you see that you have netconf with data broker, and you have the normal data broker, and you could have other ping pong data broker, a bunch of different data brokers. So we could allow the different data brokers to get involved. And that means, say for example, within one transaction, say for example, you want to programming device with netconf, and you also want to store some internal data in your data store in the ODO, you can consider this as one transaction. Either one of them fail, you could like say roll back cleanly. So this is basically say I generalizing it to say making this as a data broker. So I using the data broker to consider. So it could be netconf, or it could be devices, or it could be like a different. The second one is like auto rollback. We don't want to like say if something happened, failed, the info will be rolled back to the previous state. So which means that if whenever you say I start the transaction, when you end the transaction, either it failed. If it failed, then I need to go back to where we're starting. We don't leave any intermediate state in between. So that's the purpose for that. Then the third one is the locking. So basically say, once we start the transaction, we need to lock in the device. So basically, the main purpose is that we don't want other things can happen simultaneously. So this is more like so basically from application point of view, I have the one lock within this set of device, and internally I need to maintain the different locks to locking them. So these are the contributors. So the Maros is basically say who own the netconf. So he give a lot of contribution on here. Then Fangming and I will basically from the project which we are working on. So we are working on it. Also we have 2 interns from the BUBT, which is in the China. So they kind of like helping on this one. So contributed the unit test and the IT test. So this project I see that is a very good contribution among all the different resources. Okay, so I'll give the presentation to the Fangming, let him to go through the detail to say how we achieve it. Thanks.
Okay, thanks, Eddie. Hi, everyone. So now I'm going to go through the internal design and some implementation details. So this is the architecture of distributed transactions. Distributed transactions is shorted for DTX. So from the application point of view, so DTX is a library. So application can use the APIs provided by DTX. So and the DTX utilize the APIs provided by the specific data brokers. So in the current implementations, we have 2 data brokers supported. One is netconf data broker. So and the other one is the data store data broker. So first, in this paragraph to the upper left corner, so application use the DTX provider to get DTX transaction. So DTX provider actually is a service instance running in ODL. So basically, application need to wire the service in, so the application can get the DTX can get the distributed transaction instance. So once the application get the service, so the provider will lock all the devices that the application will operate on. So this is because the transactions are exclusive. So in the right hand side there are 2 blocks. One is called cache. So the cache in DTX the reason why we can keep the transaction atomic is so before each operation. So for each operation we will read the data first. So suppose you have some data to operate on, either write or delete. So first we will read the data from your device and save the data in your cache. So and if there are some error happens, and the data saved in the cache will be rolled back to the previous state. Means the cache data will be read to the device again. So the data is the cache is per transaction. So means it means that for different transactions they won't interrupt each other. So and the rollback component is for the error handling. Suppose you have some operations in one transaction, but one of them fail. So at this time, the rollback will happen. So the rollback component will get all the data from the cache and write all the data back to the devices. So and of course in a reverse order. The reason is, so for some data, there are some dependencies between your data. So like you have 2 configurations. So you have to first write to A and then write to B. So, if there are some error happens, so we want to roll back data, the sequence should be reverse B first and then and reverse A. So, at the southbound, there are two TX providers. One is called the Netcom TX provider, and the other one is called the data store TX provider. So these two transaction providers actually is an abstract layer for different data brokers. So because the problem is, so we want support multiple data brokers in future. So we have to provide an abstraction layer to abstract the behaviors of different data brokers. So currently we support two transaction data providers, and they are Netconf provider and data store providers. So in one transaction, there are different kind of failures. So basically, first because in the transaction, first we can read data from device. The first error may be the read error. The read error may caused by the absence of a device or some network connectivity errors or something like that. So this the first error is the read error. Second error, maybe there are some maybe suppose we are going to write data to a device, and at this time the write may maybe there are some error happen for your write. The write maybe you have some invalid argument, or the device doesn't exist, or something like that. So basically for one operation, so a lot of places may give you a lot of errors, different errors, but any of this error will be treated as an error of the operation. Yeah. Any other questions, comments? Okay. So his question is whether the rollback is guaranteed or not, whether the rollback happens automatically. The answer is yes. So the reason is, so suppose there in our implementation, once there is an error, so the rollback will roll back all the operations you have performed in the transaction, of course in a reversed order. Okay. So here is the sequence to create a new transaction. So how application should use this library? So it's quite similar to the APIs to use a data broker. So first, application should create a new transaction, and then application should use the put, merge, delete APIs to operate on a specific device. And then after the operations, application should call submit function to submit all the operations that have been performed. So this is the sequence diagram to create a new transaction. So to create a new transaction, so application has to pass all the devices that the application is going to operate on to DTX, especially more accurately to DTX provider. So application passes all the devices to operate on to DTX provider. So in the first step, so this API is a synchronous API. So the TX provider first will log all the devices. So this because the transactions are exclusive. So after logging the devices, the DTX provider will go to each TX transaction providers. So like we have Netconf data brokers, we have data store data brokers. So the DTX provider will get the real write transaction from these two data brokers. And all these transactions will be saved in DTX, so and saved in the dispute transaction handle, and return the dispute transaction instance to the application. So after 1.3, so means the TX provider returned a transaction to DTX provider. Maybe there are some error happens, so which wasn't shown in the diagram. Suppose DTX provider fails to get a transaction from a specific provider. of course, the creation of your new transaction fails, and at this time, the DTX provider will release all the devices and release all the logs and return error to applications. So here is another example to show how to do device operations. So after applications create a new transaction, so device can operate on those devices. First, the device operation APIs, they are all asynchronous. So application first issue put, merge, or delete operation to a device, and of course to a specific data broker too. And the DTX will return a future to the application immediately. So the API is asynchronous. Then DTX will read the data. Read the data the operation is going to operate on. So and read the data from data broker. So after the data broker, so after the read, the data broker will issue the real read to a device. This may be maybe a read from a device or read from a database. So the data will be read from the data broker and will be returned to the DTX. And then DTX will cache the data in your local cache. At this point, so the data you are going to operate on is saved in your local cache. And then DTX will issue the real put, delete, or merge to the device. So at this phase, the real write to device happens. And after 1.5, so the data broker will write the real data to a device or to a database. And this is where the real programming happens. After DTX gets the result of the real write, so it will save it will set the result in the future, so which was returned to the application. So in 1.7, so after 1.7, so application will be notified for the task because the task is done. So either this is a successful case for device operation in transaction. So I will talk about if there are some error happens, how DTX will deal with the errors. So any questions on this slide? Oh, okay. Suppose there are some error happens in your transaction. So at this time, so the DTX will roll back all the data that has been performed, or roll back all the data that have been written to devices. So same thing. So suppose application still issue a write to DTX. So DTX first read the data from device and save the data in a cache. So because there are many errors may happen in the procedure. So let's take the real write error, for example. And then the DTX will write the data to a device. At this time, the error may happen. So the error happens and in 1.6, and the device returns some errors, or return some error to DTX. DTX capture the error. So at this time, so DTX will roll back all the data that has been performed. So means basically what the DTX does is to read all the data from the cache in 1.4, the step 1.4, and all the cache will be read from the cache and write to the data brokers. So the data in the cache will be write into the data brokers in a reversed order. So by this way, so DTX will get the data before the transaction happens, and write the data before the transaction happens to the devices. So all your operations will be can be rolled back. So and then in this case, so DTX will set error to the future, which was returned to the two applications, and the applications will get the notification of an error for its operations. So as I have said, so there are several steps to finish a transaction. First, the creation of transaction, and then the device operations, and then finally, so application should submit all the application should do summation to submit all the operations that has been performed. So there may be some errors for the submit during the summation too. So this sequence diagram shows what will be do. So if there are some errors during summation. So first application is to submit to DTX. DTX will return a future to applications immediately. So this function call is also asynchronous. After DTX get the submission request, DTX will submit to all the devices and all the data brokers. So it means the summation is parallel executed. So and the DTX will wait for the each data broker and each device for the return value of the submission. So suppose there is no errors, 1.3 will go to 1.6, and a good result will, okay result will be returned to the application. But at this time, so suppose there was some summation error, like maybe you have some configuration collision, so on one of the device, so and you may get a summation failure. At this time, so DTX will capture the summation failure, and similarly, DTX will also roll back all the data that has been performed, no matter the summation happens or not. So, and also the rollback the data sequence is in a reversed order. So this diagram briefly describes the class diagrams in DTX implementation. So in the middle, we can see DTX is an interface. So similar as the read-write, similar as it's a subtype of write transactions. So there are four major methods in write transactions. They are put, merge, delete, and submit. So we are still using the submit method. The problem is for the first three, put, merge, and delete. So the problem is their return value is void. But for DTX, so DTX write APIs, they are all asynchronous. Maybe there are a lot of different scenarios, different errors may happen during in the programming. So in this case, we create another three new APIs called put and rollback upon failure, delete and rollback upon failure, and merge and rollback upon failure. So these are three new asynchronous APIs for DTX. DTX and the DTX implementation is a class which implements the DTX interface. So on the left hand, so there are two libraries. One is called the rollback library. The other one is called the TX cache. The TX these two are implemented in the SPI of DTX. So the first rollback is for the control logic to rollback data from devices, and the TX cache is the implementation for the cache to cache the data read from devices. So on the right hand, there are two blocks. One is called the TX provider, and the other one is called DTX provider. DTX provider is a service running in ODL instance. So applications use this TX provider to initialize a transaction, to initialize a distributed transaction. And in the TX provider is also an interface. So this is an abstract layer for different data brokers. So we have two data broker implemented now. They are data store TX provider and the netconf TX provider. So DTX provider will link these two transaction providers and utilize the service from these two transaction providers. And everything finally was integrated into DTX implementation. So and the DTX implementation is the implements all the control logic and all the control logic of DTX. And those control logic I think we have covered most of the sequence in previous slides. So for about the future work, so currently the cache we implemented the in-memory cache. The problem is, so for the in-memory cache, there may be suppose ODR instance crashed, so we cannot get the cache data back. So in future, we are planning to implement persistent data cache. So the idea is we may put the cache in the data store. So because the data store itself is persistent, so if we put the data store, so even though after ODR crash, so we still can data store back, and the operation, the transaction can still going on. So another future work is the logs. So for the log, because the transactions are exclusive, so means we have to maybe if there are some bugs in applications, so maybe a device may be locked forever. So in this case, we need to have something to recover. So our plan was to to put a timer in the implementation in the dispute transaction. So if the timeout triggers, so the device lock will be released unconditionally. So this will help for the case that the application crashes and the device won't be locked forever. So another future work is the device locks. Currently, the lock was implemented in DTX, but the problem is for different data brokers, their locking mechanisms are different. So in future, we are going to move the lock implementation into each data broker, so we can have the very data broker specific locks. So I think we still have some time. I can still talk about the current state of the project and the release plan of the project. So the current project, we have finished most of the testing, the coding of the project itself, and the most testing, including the unit test and the integration test. So we are working on some performance test. So I think maybe in short future, maybe in a couple of weeks, we can get the performance test of this feature. And also, so for the release plan of the feature, I think the feature will be released in Born, which will happen very soon. Yeah. Okay. Okay. So any questions and comments? Yeah.
So when you read the data from the device, so what exactly?
So the question is, when DTX read the data from device, so what's the data format or what's the data type from device? Is that right? What's the content? Okay. So actually, so in DTX doesn't care what kind of what type or what content of data you read from device. So because in the data broker, you pass the instance identifier to DTX. So DTX just read the instance identifier from a data broker, and the data type in the cache, because the final data read from the device will be stored in a cache. So the data in DTX, they are all has a type of data object. So it means it's a generic object rather than a specific type. Yeah. So basically, so for this question, because DTX infrastructure, so it means the DTX has to be compatible to different data brokers. So DTX doesn't handle the specific type of data. It only handles the generic type of data. The question is, so whether we cache, suppose we read some data, whether we cache all the data from the device. So the answer is yes. So still go back to the same claim I made before. So once you are accessing a data, it means you access on an instance identifier. So in the data broker, so all the data was stored in a tree structure. So suppose you are reading a node in a tree structure, you also read all the data from your subtree. So at this time, so the data itself and all the subtree will be saved in the cache. So and of course all the configuration. So take your example. So all the configuration from a device that read to DTX will be saved in the local cache. So only by this way, if there are some error happens, we can roll back the data to the previous state. Any more questions? Okay. Okay. Thank you very much. That's our presentation. Thanks for coming.